Good evening, everybody. Thank you for watching my tutorial. This tutorial will cover how to troubleshoot choppy audio. So I work in a call center in which we get all types of calls. Could range from I'm getting reports of one-way audio, I'm getting reports of no audio, and the other issue that you may see is I'm getting reports of choppy audio or garbled audio. I've done a couple of other videos showing how to isolate no audio and one-way audio, and this video will concentrate on how to troubleshoot choppy audio. And this is my way of doing it. There may be other ways. There may be better software to do it. I use Wireshark primarily for troubleshooting VoIP issues. And I often refer to telecom techs that are familiar with having a butt set on site. I often tell them, that Wireshark is the new butt set for voice over IP. So you wouldn't go to a job site without the ability to tap into the phone lines and to hear what's going on before the lines actually hit your phone system. And in my opinion, the same is true for digital or VoIP telephone lines as well. You don't want to go to a job site and not have the ability to see what's happening in front of your PBX or in front of your phone system. So what I have here is I have an issue where a customer has complained of choppy audio, and they're complaining of choppy audio at this phone here. And we were able to capture an instance today where they confirmed it was choppy audio. And I was actually running 2 Wireshark traces. And the benefit of having 2 traces is if I only have a trace at this point, then the only thing that I can say is, yep, I'm receiving choppy audio. But what I don't know is, was it ever clear audio, or did the problem start all the way over here? So if you take a Wireshark trace at 2 separate points simultaneously for the same call, then what you can do is you can do a comparison between those 2 traces and get an understanding of what left this side over here and what was received at this side here. So I'm going to go ahead and jump to show you exactly what I'm going to be doing here today. So we'll go ahead and go to slide 2. And this isn't all going to be a PowerPoint, so don't bail out on me yet. I'll actually show you how to do the analysis. But basically this is the end results of what I found after doing the Wireshark analysis, and then I'll show you how I came about these conclusions. So what I found is that from this IP phone here, we transmitted 1,453 packets through the switch, through a router, through a firewall, over the internet. And at some point between this red line and this red line, we lost 380 packets. So either over the internet, the customer's internet connection, which for this particular customer was a 50 meg connection down and a 10 meg connection up. So we either lost it here on the transmit side over the internet, or at the firewall, behind the firewall, at the router, or behind the router. And so we were capturing on the back side of the router with port mirroring on a switch. So I had one laptop running here on this switch here, and I had another laptop that was basically, I have another switch that's here that's not shown in this picture, and I was doing port mirroring here so that I could see what's happening on the front side of my router. So this is basically on the public internet, or just before it goes to the public internet. So by looking at this trace, I was able to see 1,453 packets were sent from this location that passed this trace here. And when I looked at the trace on the remote side, we were only able to see 1,073 packets. The other thing that I did is I took the packets, and I actually, and I'll show you how to do this as well in just a minute, regenerated the audio from the packets, and it was a little bit tricky because the codec was G729 and not G711. What I found is in Wireshark has a native player built into that will play G711 codec straight from Wireshark. However, if it's the G729 codec and you try to play it, I'll show you in a minute, you get little, you'll get a blank space basically, and it'll look like it's playing, but you won't hear any audio. You actually have to do a little bit of converting, and then I used Audacity to play the file back. And I was a little thrown at first when I first started playing the files back, because this section right here is my actual transmit side. So this is the 1453 packets that left this phone. This audio sounds really good, and my words in this audio sound very pronounced. So if I pause or if I say the word and I, 1, 2, it sounds very pronounced, and you can hear that that there's a little bit of length in my words. When I played this trace back, all of my words were there, but what I heard was 1, 2, 3, 4, 5, and I was like, I know I did not say that fast. I said, what could be the issue? So what I realized is by the time I got through converting the packets, it didn't take into account for the 26.2% of dropped packets. And so this is about 26% of the call that's missing here. What it did is it slid everything to the left, and so basically my words were shorter, so the packets that got dropped, they just left those out and then squished everything together, and so I ended up with this file, and I sound like Mickey Mouse. This isn't 100% accurate of what they probably received on this side, but it's a good visual demonstration of what actually happened. So on this side, they probably heard, silence or gaps in my words, but what I'm looking at is I took all the packets that I captured here, and without the silence and gaps, and it squished them all together, and now I've got one continuous file, but my words sound a lot shorter and a lot less pronounced, if that makes sense. So basically what I was able to show or demonstrate to the customer is that 1,453 packets left site A, left this point here, and somewhere between this point and this point, which is pretty much the customer's data router, data firewall, and the pipe coming down from the internet, we lost 26.2% of those packets. So what I'll do now is I'll go over to Wireshark and I'll tell you how I was able to pull all of this information together. So we're going to go, no, sorry, wrong computer. So this is the Wireshark capture that I took, and this is the transmit side. So if I go look, back here, so the first packet capture that we're going to look at is the transmit side of the packet, or the transmit side of the conversation. So it'll be the capture from this computer here, remote capture point. Okay. So here we are in the remote capture point, and if you'll notice, the first thing we have to do is tell Wireshark what type of traffic we're decoding, because right now it's trying to decode it as IPv4, and if I try to use any of the telephony tools here, it's going to tell me I didn't choose an RTP packet. So what I have to do is I know this is RTP traffic. One other thing I want to point out is typically when you do a Wireshark trace, you will capture both sides of the conversation, the transmit and the receive. In this particular case, the receive traffic at this particular phone was fine. So I didn't, to clear to make it less confusing, so there's not both sides of the conversation, I stripped out all of the receive packets. So now we're only looking at the packets that were transmitted from this phone and the packets that were received at this phone. So I'm only looking at one side of the conversation. Okay. So we're going to go back to Wireshark. Okay. Here we go. So now I've got these IPv4 packets, and I need to convert those to RTP packets. So we're going to right click and decode as, and scroll down. And we'll select RTP. And you can click apply, and then it'll run through and it'll convert everything, and then when you click OK, it has to do it all over again. So I try to get in the habit of just clicking OK. That way you only have to do it once. And so now it's converted. And if you look down here, these are, you can see the number of packets. So I've got 1,453 packets. And if I go back to my slide here, that's exactly what I showed here, was 1,453 packets transmitted, right? So that's where I got the first number from. So 1,453 packets, now they're converted to RTP packets, and then we're going to go to telephony, and we're going to go to RTP stream analysis. And so this gives me information, periodically throughout the conversation. And then what I'm really interested in is if I tried to click player now and hit decode, if this was G711, what you would see is you'd see a crystal clear image of kind of the speech going back and forth, and you'll see that demonstrated in my other videos. This is the G729 codec. So it's not able to be played directly from Wireshark. So what we have to do is save this payload, which basically means create an export of the audio in the raw format. So what we're going to do is save payload, and we're going to say this is ATG transmit. And I'm going to call it demo because I've got a few other versions on here. So ATG transmit demo, saving it in this folder G729. And format is going to be raw channel. This is the forward direction. The reverse direction, like I said, I've already stripped out the reverse direction. So if I tried to click on that, it would tell me, hey dummy, there's no reverse side of this conversation. So I only have one direction of the conversation. And so we'll click OK. And so now that file has been saved, and if I go look over here, I didn't like that, so we'll go, because I didn't put an A on the end of it. So if I go look over here, then the name of that file was ATG transmit demo. So I've got a 29 kilobit file that it created. And notice it doesn't have an extension on it. So real quick, we're going to change this to .raw. Okay, so that is that side of the conversation, and I've exported that as atg.raw. I'm going to go ahead and show you all the way through on just this piece of it, and then I'll do it again for the receive side. So we know the file's there, and we're going to go here, and there's this software that I was able to download off the internet. And it's free for non-commercial use. So since I'm only using this for demonstration purposes, we are good to go. So it's Codec Pro Incorporated is the name of the company. And basically what you do here is extract their program into just a common folder here, and they have an executable that you would run from a command line, and then you put in the name of the raw file. So in this particular case, let's go see. I have a very short-term memory, so I need to go see what I actually called it. There's a way, probably a better way we can do that, which is just a directory. And just because I'm not real sure how, I've always had a couple of issues with DOS prompts or command prompts and spaces. So what I'm going to do is go into this folder here and just take out the spaces so I don't have to worry about that causing any issues. So we have ATG. So if I close this out, run another demo, we've got ATG transmit demo. Okay. So now I've got my program running, and then we're going to go ATG transmit demo. And then we'll do the same thing, and basically what we're doing is we're converting it from the raw format to the PCM format. So ATG transmit demo. Okay, and after you do that, you press enter, and it comes back and it says, this is kind of a good sign for success. Input bitstream file, this is my original file, this is the export file, and this is shows me that it decoded the frames. It didn't give me any error messages. So now if I run directory again, I will have ATG transmit PCM. If you notice, it's a little bit larger file. Alright, so now the next issue is how do I play ATG transmit PCM? And these were from earlier, so we'll go ahead and close these out. And so basically this is Audacity. This is another free download off of the internet. So I'm going to go ahead and go to File and Import and Raw Data. And from raw data, now we're going to import the PCM file. And this needs to be set to 16-bit. This needs to be set to little and then end IAN, one channel mono, and then 8,000 hertz is what that needs to be set to. And if I hit import, then we get a nice clean audio file here for playback. So this playback file here is the same file that was listed over here. This is the transmit side is what we're looking at. So now we need to work on this side, which is the receive side. So what we'll do here is we're going to go back to my Wireshark computer, and we're going to go bring up the ATG receive side trace. So this is the 1453 packets. This is the 1073 packets. So this is my trace that I took. Sorry, I'm bouncing back and forth, but I just want to make sure to cover everything. This is the trace that I'm taking from this point here. So behind the customer's router, behind the customer's firewall, there was a switch, and basically we went into the switch and configured it for port mirroring and mirrored all that traffic to a computer. And when we counted the packets, there were only 1,073 of them, even though 1,453 were transmitted. So we're going to go back over here, make sure we're on the right trace. Yes, we are. This file has already been converted to RTP. So what we'll do now is we're going to go to telephony. RTP stream analysis. And you can already see that it's saying, hey, there's some issues here, but we're going to go ahead and save payload back in my G729 folder, and then we're going to call this ATG receive demo. And you can also put that .raw on here as opposed to doing it with Windows after the fact. So ATG receive demo.raw, click OK, and close that out now. Now we're going to go back to my 729 directory, and I should have another ATG receive demo.raw. There it is. And we're going to go up arrow in DOS to bring up previous commands. Alright, and so converted my file. Now I have a PCM, so if I do directory again, I have both my PCM and my raw. So now, go back into Audacity. We're going to go File, Import, Raw Data, and we're going to look for the PCM version. Click Open. Same thing, so this is going to be 16-bit, little end IIN, one channel. Sample rate, slow it down to 8,000. Hit Import, and there you go. And you'll see almost immediately that their conversation here is a lot shorter. I'm going to try to play these files back over the video that I'm taking here and see if you guys can hear them. And if not, you are welcome to take these traces and regenerate these files yourself, and you can hear the difference. And this is kind of a mild difference. The customer reported that it gets more severe, but this was a notable, a notable issue. So we took the traces and we were able to actually see the issue. So sometimes, if it's very minute, you may not catch it or be able to see it, because some packet loss is normal. But in this case, it was pretty significant. But you'll see how it affects the audio when you play the audio back. So I'm going to go ahead and play the original. Oops. So what we're going to do is trying to play both sides of the conversation at once. Still not 100% familiar with Audacity, so I want to start. I'm going to mute this side over here. Oops, muted both of them. So here we go. Here's the transmit side.
Steve. Hey, still getting a busy signal for some reason. Still sounds good here. How about you? Okay, test 1, 2, 3, 4, 5. Okay. All right, well, let's take a look at that trace then. All right, bye.
Okay, and so that one's done. We're going to go ahead and mute that. Unmute this one, and...
Hey, Steve. Hey, still getting a busy signal for some reason. Still sounds good here. How about you? Test 1, 2, 3, 4, 5. Okay. All right, well, let's take a look at that trace then. All right, bye.
Okay, and so with that file being played back, that's what the person on the other end of the conversation was hearing from me. So I was able to capture that and play it back. And you can hear when I'm counting, you can even see it here, is these are very spread out, so you can see the amount of time that it takes to say 1 here, 1, 2, 3, yeah, so 1 here, as opposed to what it took to say it here. It's a much shorter. So all of the sections are present in the conversation. So if you look here, and here, and here, and here, this one matches with that one, this section matches with this section matches here, and this section matches here. So it's all present. It's just this, because there's so many dropped packets, this has all been compressed down. Now, again, one more time, I want to say is this is not a representative of what the person actually heard, because what they would hear is they would hear the same time span, but they would hear basically they'd hear me say 1, 2, 3, 4. Yeah, it would kind of sound like that. So, but when I do the conversions and I spit all the data out, it takes out all those blank spaces and squishes everything together. So you can visually see how much, what percentage of the conversation was actually lost over here. Okay, guys, well, that's it for this tutorial. This is probably one of the best examples I've seen of being able to troubleshoot troubleshoot one-way audio, choppy audio. There we go. It's the end of the day, guys. Sorry. So really, it's capturing the Wireshark trace at 2 different points on the network, and then comparing those traces and listening to the audio as it left, and listen to the audio as it arrived, and listening to the difference and doing the packet counts is a real good way to demonstrate to a customer or a client that they are indeed seeing packet loss between these 2 points. Now, if they wanted to take it one step further, we could take this, packet capture and move it, in between their router and firewall. And maybe we don't see as much packet loss, and maybe then they need to target their router. You can also take it and move this trace here. And also do a packet capture here as well, and then you can see if it's happening just on this side of the customer's pipe. Then you may have to get your ISP involved and say, hey, do a trace on your side, because I'm definitely not seeing the packets on my side. So you can use Wireshark and take all these different segments of the network and break them down. My objective was to demonstrate that it was not an issue being caused by the PBX. So I took the widest, a pretty wide approach at looking at the network and demonstrated, hey, I'm capturing the data after it leaves the phone and bypasses all my network equipment right here. Sounds fine, but by the time it gets over here, it sounds bad before it even gets to my phone. So I was able to demonstrate, the packet loss here. All right, guys. Thank you for taking the time to watch this video. If you like it, share it, like it, make a comment, let me know what you think. If you don't like it, let me know that as well, because I will use that to make future videos better. And I'll also post links to the Wireshark traces, which I had requests in previous videos, but I didn't have the traces anymore. But I'll post links for these videos, or for these Wireshark traces that I used to generate this video. All right, guys, have a good one. Thanks for your time.